Okay. So that's what we'll look at in section 8.1, dealing with variables. Let's talk about what a variable is. Okay, so of course, variables are nothing but letters of the alphabet that are used to represent numbers or elements of a given set. Okay. So here we have fixed numbers or constants when we're dealing with basic arithmetic. But here a major concept of algebraic thinking would be that of a variable. And here's how variables can be used or represented. It may stand for a missing element or an unknown, like in the equation x plus 2 is equal to 5. So in other words, that means what number plus 2 would give us 5? That would be, of course, 3. So that missing element or the unknown would be x is equal to 3. Also, a variable can represent more than one thing. Okay. So in other words, x, of course, can be represented for anything. Like if I want to know the number of students in a classroom, that could be x being the number of students. Or if I want to know how much older is one person is than another, then x will be that difference between two people's ages. Also, a variable can be used to generalize patterns. Okay. And a variable can be an element of a set or a set itself. Like, now you've probably seen this back in chapter 1 somewhere. Or in math for teachers, one where you have A is greater than, A intersect B. What that means is in set building notation, it's going to be the set of all x values such that x is an element of A and x is an element of B. Those are just some ways that it can be represented as an element or a set itself. Or probably in college algebra, you've probably seen something like this. For a solution set, let's say the interval notation would be something like -3 to 6. That would be something like the set of all values of x, such that -3 is less than, actually just strictly less than x and less than 6. Those are just illustrations of how the variable can be used to represent an element that belongs to a set. And in math, we call that set builder notation. All right, so back to this. So let's say we want to solve problems algebraically. What we do there is translate given information into mathematical expressions involving variables designed by letters. Now, an algebraic expression is nothing but an expression containing one or more variables with no equal sign and is not an equation. Because if an equation did have an equal sign in it, then you would have something called an equation. That's a statement of equality between two expressions, saying that one expression has to be equal to the other expression. All right, so in this first example that I have up here, let's say I want to translate the following phrases into algebraic expressions. Let's say I want to write a expression like this. The sixth term of an arithmetic sequence whose first term is 15 and whose difference is D. Say we have the sixth term of an arithmetic sequence whose first term is 15 and whose difference is D. All right, so in this case here, I'm gonna go and pull up this. It's on a Blackboard. It's already, it should be already up there on Blackboard right now as I speak. Okay. All right, so the sixth term of the arithmetic sequences, first term is 15, and the difference is D. Well, that first term is going to be 15, and it has to be plus something. And of course, well, actually, yeah. And that difference, of course, is D. So you have to think of this 15, and then here's the sixth term right there. And then we have to find the common difference here, which is going to be D. So in this case, if we're adding D each time, and how many times are we adding D? 5 times. So it'll be 15 plus 5D. Okay. So that would be the expression for that sixth term of the arithmetic sequence, whose first term is 15, and the common difference there is D. Because the first number is going to be 15, and then we're adding D, whatever that number is, 5 times. So it'll be 15 plus 5D. Okay. Any questions on part A? Okay. All right, now part B. I'll write this up here. 10 less than a number, less than twice a number.
We have to solve A.
It's just an expression. It's just an expression. Okay. We don't need, it's not an equation, because an equation has to have an equal sign in it. And in this case, when it does not have an equal sign in it, and they did say just translate it into an algebraic expression. Okay, now part B. 10 less than twice a number. Now you want to be careful how you translate that into a algebraic expression. It says 10 less than twice a number, which means we need to translate twice a number first. So twice a number would be something like 2n. And the phrase less than means to subtract. Okay. Or another way of saying this would be, we subtract 10 from twice a number. So here, this will be the expression 2n minus 10. If it's written like this, 10 less than, yeah, twice the number, has this 2n has to go in front. And then minus 10. All right, any other questions about part D? Okay, part C is 10 times the square of a number. Ten times the square of a number. Okay, so if I want to translate that into an algebraic expression, this will be, of course, 10. And of course, you can write this with a multiplication symbol, the square of a number. That'd be n. And if we're going to square it in, it'll have to be with an exponent of 2. So it'd be 10 times n squared. Or another way, just writing it, you can just write that without the multiplication symbol. They both mean the same thing. It'd just be 10n squared. Questions on part C? All right, now part D is this, the difference between the cube of a number and twice a number, twice the number. All right, so if I want to translate that statement or phrase into an algebraic expression, what would that be? This is a number cube. We'll use n for the number, or you can use any variable you like. It'll be n cubed, and then subtract. Yeah, we're going to use n.
Would you square it? Would you just?
It's twice. It says twice the number. It's 2n. Okay. So the n cubed minus 2n. All right. Any questions about example number 1? Just translating into a algebraic expression. Okay. All right, so I'll go back to this. Scroll down. All right, here's a couple of examples. These deal with writing an algebraic equation, so we know we're going to need an equal sign in these problems here. Like in example 2, if the number of professors in a college is P and the number of students S, and there are 18 times as many students as professors, write an algebraic equation that shows the relationship. So let's say we want to write an equation for this relationship, showing the relationship between the number of professors and the number of students. Okay. Well, it does say here that there are 18 times as many students as professors. So the way I would write that would be this. I'm going to start with the S for the number of students, since there are 18 times as many students as professors. So that's going to be equal to 18 times P. So S is equal to 18 times P. Excuse me. Now, of course, if I knew the number of professors, then I can find out the number of students at a college by taking the number of professors, multiplying it by 18. Okay. All right, questions on example 2. Okay. All right, now in example 3, if G is the number of girls in a class and B is the number of boys, and if there are 2 more girls than boys in a class, write an algebraic equation that shows this relationship. Are there any ideas how to write that equation? G is equal to B plus 2. Okay. All right, so here, G is the number of girls. There are 2 more boys. 2 more girls than boys. So we take the number of boys, add 2 to it, and that will equal to the number of girls in that classroom. Okay. Questions on example 3. Okay. Trying to get back to this right here. Okay, here we go. All right, example 4 is there are 2 parts to this. Let's say I want to write an algebraic equation relating the variables described in each of the following situations. Like in part A, the pay, which is P for T hours, if you are paid $21 an hour. All right, so for part A, what would be an algebraic expression for this? Okay, P is equal to 21T. P is equal to 21T because it's $21 an hour for T hours. And that would be what the pay is equal to. Now in part B, they say here that the pay P for T hours, if you are paid $19 for the first hour and $14 for each additional hour. Well, we know we gotta have P is equal to, and you're paid $19 for the first hour, $14 for each additional hour. Almost. Well, the 19T, well, the 19 would be right. And that's only going to be for the first hour. It says for each additional hour. So that means it's got to be this 14 times, and this will have to be T minus the first hour. Everyone see where I got the T minus 1 from, because that first hour, that person is paid $19. The remaining hours will be paid $14. So it's T minus 1 times the $14, and then we add $19 to it. So that would be the algebraic equation for that situation. Okay. Questions on that? Okay. All right, example 5 looks like this. If a school has W women and M men, and you know that there are 210 more men than women. Write an algebraic equation with relating W and M.
What was the answer you used?
Yeah, what would that be?
M equals W plus 210.
Right. Number of men is equal to W plus 210. Okay, because there are 210 more men than women. Okay. M is equal to W plus 210. Okay. All right, questions on example 5. Okay, and example 6, Matt has 7 times as many stickers as David. If David has D stickers and Matt has M stickers, and Matt gives David 6 stickers, how many stickers does each have in terms of D? Okay, think you know?
So M equals basically 17. Matt is equal to 17.
Okay.
That's my day.
Let's just say M,
Yeah.
that's for Matt, and it's equal to 7D.
So if Matt gives David 6, I would say 70 plus 6 equals M. I don't know if I'm right.
Okay. Okay, we're letting D be the number of stickers that David has. Okay. And Matt has M stickers, so that means M has to be equal to 7 times D for Matt. But here Matt gives David 6 of his stickers, so the number of stickers that Matt would have would be 7D minus 6. But David picks up 6 stickers plus 6.
I have a question.
Yes.
Okay, so So why would it just be D plus 6?
Okay.
But you have to pick that unless, because you already solved for D, is that one?
No, it's just going, in his case, it's just going to be an expression. Okay, it's just going to be D plus 6 for David, because that's how many stickers he will have. Okay. And in this case, for Matt, we can say M is equal to 7D minus 6. Okay. All right, any other questions? Okay. All right, so that's pretty much how we write algebraic equations or translate sentences into algebraic equations. All right, the next thing we'll look at is arithmetic sequences. Now, in this case here, probably, I don't know if you've seen this before, you probably heard of arithmetic sequences. But if you're not familiar with it, here it is. When arithmetic sequences is just a sequence in which each successive term from the second term on is obtained from the previous term by adding or subtracting some fixed number. Okay. So for such an arithmetic sequence, like, let's say, we'll start with 5, and then 9, 13, 17, 21, and so on. That would be an arithmetic sequence. And the reason for that is we're adding the same term or the same number each time, which is called the common difference. Okay, because here, from 5 to 9, I'm adding 4. From 9 to 13, I'm adding 4. From 13 to 17, I'm adding 4. And from 17 to 21, I'm adding 4. So if I want to get the next term of that sequence, I just have to add 4. Okay. So that D equal to 4, that's what we call the common difference. So that's the common difference. And also if I had something like this 84 and let's say 78, 72, 66, and so on, that too is a arithmetic sequence because instead of adding something, I'm subtracting the same number. So here I'm subtracting 6 each time. So if I want to get the next number after that sequence, I'll subtract 6, and so on. So that's what an arithmetic sequence is. Okay. And on the handout is the way that we find the nth term of any arithmetic sequence. Here you're given the first term, which is a sub 1, and the difference will have to be D. And in this case here, it's going to be a sub n minus a sub 1 plus n minus 1, and that should be times D. So there should be a D after that n minus 1. Can't believe I left that off. But it's a sub n is equal to a sub 1 plus n minus 1 times D. Okay. So it should be a D right behind that n minus 1. Okay, so in example 7, you're given this in each of the following arithmetic sequence, you're going to find 2 things. The 100 term which is going to be part I, and then part N would be the nth term of that sequence, of each sequence. All right, so in part A, say we got this 0, -6, and -12. And it goes on and on and on without end. Okay, so in this case here, I want to find the 100th term and the nth term. So in part I want the 100 terms, so that means n has to be 100. Now I need the common difference here. I'm going from 0 to -6 to -12. What would be that common difference? -6, because I can subtract. Or in this case, I can add, in this case, -6. And then I'm going to use this arithmetic sequence formula, which is a sub n equaling to a sub 1 plus n minus 1 times d. And of course here, your a sub 1, what's the first term? 0. So a sub 100 would be equal to 0, which is the first term, plus n, which is 100, minus 1, times d, which is -6. So this will be 0 plus 100 minus 1 would be 99 times -6. So no, that's 0. But what's -99 times, well, what's negative, well, 99 times -6 is what? -594. Okay. So the 100 term of this sequence would be -594. Okay. So that's part I of part A. Now, part II of part A would be finding the nth term. And that's for this situation here, okay? Now here, we already know what the common difference here is. That common difference, again, that's -6. Okay. Well, there yet, let me write this over here. In terms of what we're looking for, the common difference is -6. We're going to use this right here. So this will be a sub n equaling to a sub 1 plus the n term would just sort of say n minus 1, but just substitute the d with -6. Oh, and the a sub 1, the first term was 0 in this sequence. That first term, a sub 1, is 0. All right, so now let's simplify this part right here. Here I'm going to distribute the -6 over the n and the -1. So -6 times n would be -6n, and then -6 times that -1 would be +6. So if I simplify that, this will end up being -6n plus 6. -6n plus 6 will be the nth term of this sequence here in general. Questions on part A? Okay, part B. Let's say we got this, 3/4, 1, 5/4, and so on. And again, we're going to find the 100th term of that sequence and the nth term of that sequence. Well, first of all, we're finding the 100 terms, so n is 100. A sub 1 is what? 3/4. That's the first term. Now we need the common difference. It'd be 1/4. Because 1 whole is like 4/4, and from 3/4 to 4/4, that difference will be 1/4. Okay. And now we use the formula for the arithmetic sequence for finding the 100 term of this arithmetic sequence. So we have A sub 100, and that's equal to A sub 1. That's 3/4 plus 100 minus 1 times the common difference of 1/4. So here, A sub of 100, that'd be 3/4. 100 minus 1 will be 99 times 1/4. So I'm going to bring down the 3/4. That 99 would be 99 over 1. So 99 times 1 would be 99 over 1 times 4, which would be 4. So 3/4 plus 99/4 would be 102 over 4. Now, if you want to, you can leave that as 102 over 4, or try to reduce it by dividing the numerator and the denominator by 2. That'd be 51 over 2. Or as a decimal, this can be written as 25.5. So that would be the 100 term of that sequence. All right, questions on just the I part. And then the second part, they want the nth term of that sequence. Yeah, the nth term. You're still going to have n is equal to, well, it's just going to be general. The nth term, you're still going to have your common difference of 1/4, and A sub 1 will be 3/4. So in this case here, this will be A sub n is equal to A sub 1, which is 3/4, plus n minus 1 multiplied by 1/4. All right, let's see what we can do with this here. Bring down the 3/4, distribute the 1/4 over the n minus 1. This will be 1/4 times n, or 1/4 n, minus 1 times a 4th would be 1/4. And then combine like terms. 3/4 minus 1/4. Well, 3/4 minus a 4th, that would be 2/4 plus 1/4 n. But we can reduce 2/4 to 1/2. So the nth term of that sequence will be 1/2 plus 1/4 n. Questions on part B? And part C, we got 22, 19 and a half, 17. Okay, so here we're going to find the 100th term first. So a sub 1, that's 22. What would be the common difference here? -2.5. Well, let's say I want to write that as an improper fraction. It'd be -5/2. Again, 2 times 2 would be 4 plus 1 would be 5. Bring over the negative. So the common difference there would be -5/2. Okay. So here, a sub n of n would be a sub 1 plus n minus 1 times d. And here we're finding the 100 term, so it'll be a sub 100 equally to a sub 1, that's 22, plus n, which is 100, minus 1, times d, which is -5/2. So this becomes 22 plus 100 minus 1, that's 99, times -5/2. We'll treat that as 99 over 1. So this will be 22 plus 99 plus negative times -5 would be -495 over 2. And this is where we're going to have to use that calculator to do this. 22 plus, and in parentheses, -495 divided by 2. This is what it's going to be as an improper fraction. -451 over 2. Also, you can write that as -225 and 1/2, or you can write that as -225.2. All right, any questions about part I of part C?
Does that say -451?
Yeah, -451 over 2. That's a 100.
Wouldn't it be -225.5?
Oh, you're right. So my calculator, I don't know why I wrote that. Because 1/2 is 0.5. Any other questions or corrections? Now we're going to find the nth term of this sequence here. Okay. Again, the common difference is that -5/2. And the first term is 22. So here a sub n would be equal to a sub 1, that's 22, plus n minus 1 times d, which was -5/2. So a sub n is equal to bring down the 22 plus, and then distribute that -5/2 over the n minus 1. So -5/2 times n would be -5/2 n. Negative times a negative will be a plus, so 1 times 5/2 will be 5/2. Okay. Now 22 plus 5/2. Or you can do 22 plus 5 divided by 2. That'll give you 24.5. Plus a negative, I'm going to write that as just minus 5/2 n. And I'll give you the other way of writing this. If I wrote 24.5 as an improper fraction, it would be 49/2. So it'd be 49/2 minus 5/2 n. I wrote it 2 different ways. Okay. Now, if we were using my math lab, which would end up costing you more money, pretty much I would probably give you the way that the my math lab system would want you to give that answer, because they are very picky. But since we're not, either way is fine. All right, any question about arithmetic sequences? And how to use a general form for finding the in term of any arithmetic sequence. Okay. Now let's talk about geometric sequences. In a geometric sequence, each successive term is obtained from its predecessor or the one before it by multiplying or dividing by a fixed non-zero number. And we call that the common ratio, which is denoted by lowercase r. So a geometric sequence would be something like this. Let's say it had 3 and then 9, 27, 81, 243, and so on. This is an example of a geometric sequence. Because in this case, I'm multiplying by a common number. So from 3 to 9, I'm multiplying by 3. And to get from 9 to 27, I'm multiplying by 3. And I'm doing the same thing all the way through. So here, this is what we call a common ratio. We're calling that a common ratio. And here is the general formula for finding the n term of any geometric sequence. And that's a sub n, and that's going to be equal to a sub 1, which is the first term, multiplied by r, and that's the common ratio, raised to the power of n minus 1. So now we're going to apply that formula or that general formula for finding a n term of any geometric sequence to these examples on the next page. Says here, in each of the following geometric sequences, find part I, the fifth term, and then part double I, the nth term. Okay. And we will start with part A, which is in this case, I can erase this. In this case, it'll be 1/3, 4 ninths, 16 27ths. And this does continue. So here we're going to find the fifth term of that sequence, the fifth term of this geometric sequence. So for the fifth term, it has to be n is equal to 5. We need something else. The R, which is a common ratio. What would be the common ratio for this? Well, let's take a look at the numerator here. We're going from 1 to 4, and then from 4 to 16. That numerator is being multiplied by what? Okay, we're going from 1 to 4, and then from 4 to 16. What number are we multiplying by?
4.
By 4. Because 1 times 4 would give you 4, and then 4 times 4 would give you 16. Everyone see that? All right, now for our denominator. From 3 to 9 to 27.
3.
We're multiplying by 3. So the common ratio has to be 4/3. Okay. And we're finding the fifth term, so n is equal to 5. So a sub n is equal to a sub 1 times r raised to the n minus 1. Okay. N is 5, so a sub 5 would be equal to a sub 1. What's the first term in that sequence? What's the first term? 1/3. So a sub 1, that would be 1/3 times the r, which is 4/3. That's raised to the n minus 1. Well, n is 5, so that'd be 5 minus 1 for that exponent. And then we simplify this, so a to the fifth, a sub 5 would be 1/3 times 4/3. 5 minus 1, that's going to be 4. Now with this, we start by using the order of operations by doing the exponents first. That 4/3 will have to be to the 4th power. So here I'm going to have 1/3 times, let's see, 4 to the 4th. Okay, when you have a fraction raised to a power, you take the numerator to that power and the denominator to that power. So 4 to the 4th, that's 256. Over 3 to the 4th. That'd be 81. Okay. And I don't think you can do any cross dividing, so you just got to multiply numerator times numerator and denominator times denominator. So 1 times 256, that's 256 over 3 times 81. That's going to be 243. So the fifth term of that sequence will be 256 over 243. And this cannot be reduced in simplest form. So that would be the final answer for that. And then part double I is the nth term, finding the nth term. So again, a sub n is going to be a sub 1 times the ratio n raised to the n minus 1. So the only thing we substitute here is what a sub 1 is, that's the 1/3. And your r, which is 4/3, raised to the n minus 1. And that's going to have to be as far as we can go with that problem. So this is it. Okay. And I'm not going to be able to multiply 1/3 times 4/3 because that 4/3 is raised to the n minus 1. Okay. Questions on part A? All right, now part B is this. Say you had something like this. This is a geometric sequence. Square root of 3, and then 3 square root of 3, and so on. Again, we're finding the 5th term of this sequence. Okay. A sub 1 would be the square root of 3. But who can tell me what the common ratio is? Any ideas? All right, let's think of this. The square root of 3 times what gives me 3? Would it be this? It would, because if I take the square root of 3 times the square root of 3, I can multiply what's underneath the radical to get the square root of 9. But what's the square root of 9? 3. So the common ratio has to be the square root of 3. And now to find the 5th term of that sequence, of this geometric sequence, that means a sub 5 would be equal to a sub 1. Or, well, a sub 1 is the square root of 3, multiplied by the common ratio, which is the square root of 3, raised to the n, which is 5, minus 1. So we got the square root of 3 times 5 minus 1 would be 4, so this will be the square root of 3 raised to the 4th power. All right, so the next thing I need to do here is start with the exponents of this. Now, what I'm going to do here, the square root of 3 and it's raised to the 4th, another way I can write that would be the square root of 3 to the 4th. I can put that exponent next to the 3 underneath the radical. Here, this means the same as this. Now I need to know what 3 to the 4th power is going to be. Which is the square root of 81. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. So I have the square root of 81. Now what is the square root of 81? 9. So I'm going to put the 9 in front of this square root of 3. And that would be the 5th term of this geometric sequence. questions about that first part in part B? And now for the nth term. Of course, this is a sub n equaling to a sub 1. That first term was the square root of 3 times r, which is also the square root of 3, raised to the n minus 1. That would be the general form for finding the nth term of this geometric sequence. And that would be as far as I can go in simplifying that problem. All right, any questions on part B? All right, and part C. So we got negative 1/3, and then 4/9, then negative 16 over 27, and so on. Well, guess what? That's similar to part A that we just did. Only thing different here is that we're alternating negative, positive, and then negative. So we're finding the fifth term here. And this time, your a sub 1, that's negative 1/3. What would be your common ratio? Negative 4/3. Okay. Because now we're alternating negative to positive and then from positive to negative. So the ratio has to be a negative. And we already talked about 1 times what number gives us 4, and 4 times what number gives me 16 has to be 4. Same with the 3 and the 9 and the 27, that common ratio is 3. So the whole common ratio will be negative 4/3. So now to find the fifth term, using this a sub 5, the fifth term would be a sub 1, that's negative 1/3, times r, that's negative 4/3, raised to the n, which is 5 minus 1. And 5 minus 1 will be 4, so a sub 5 will be negative 1/3 times negative 4/3, that's raised to the 4th power. Now, negative to an even power, of course, will be even. So I'm going to bring down the negative 1/3. Now, negative 4 raised to the 4th was 256. And then 3 to the 4th was 81. So if I multiply this out, this will be negative 256 over 243. So it's pretty much the same answer in part A, but only difference here is that the fifth term would be negative. And that would make sense because first term is negative, second term is positive, third term is negative, the fourth term would be positive, and the fifth term should be negative. And then for the nth term, this here, we're still going to use this formula. So the a sub n is equal to a sub 1, that was the negative 1/3, times r, which is the negative 4/3, raised to the n minus 1. And that will be the general arithmetic sequence that would fit this situation. All right, any questions on part C, or any questions about those geometric sequences and how to find the indicated term and then the nth term? Okay. Well, the last thing I'm going to cover, and it won't take long for this one. You might have seen this on Facebook. where people will put out one of those puzzles like this one and then try to have you solve them. But here, this is where algebraic thinking comes in. Okay. And we can use pictures like this. And right there, they show you, can you solve this? So here we got the sum of 3 bulldogs equals 15. A bulldog plus I'm not sure what type of dog that is. It's probably a Dalmatian. I don't know. I'm not sure. What was that? Yeah, probably a Dalmatian plus another Dalmatian is 13. And then a Dalmatian plus 3 bones plus another 3 bones equals 10. And then the last line, you have a Dalmatian plus two bones times a bulldog. And it's equal to what? Okay. But I see the 3 bulldogs. Each one.
Bulldogs, 5 apiece.
Yeah, that's 5 apiece. And then the 5, then for this next line here, that's the bulldog. And then
Dalmatians are 4 apiece.
each, that's 4. And then this is 4,
Those are 3.
3, and 3 makes 10. This is 4. Look carefully. Order of operations. Order of operations. That's 2 times the 5, that's 10.
Plus 4 is 14.
Plus 4 ends up being 14. See, that's how they trick you with that. Okay. All right, questions about section 8.1. All right, and with that, we will end right here.